So we started a new project. I'm making a new file on my project, calling it lecture in. And we're going to be talking about formatted output. Formatted output means controlling the spaces and the number of decimal places in your output. So I just pasted my boilerplate here. So, for example, x is equal to 13 divided by 7.0. Let's make that a double. X is equal to 13 divided by 7.1. Something like that. And we want to print it out. Cout, arrow, arrow, x equals space, end quote, arrow, arrow, x, arrow, arrow, ENDL. Now 13 divided by 7.1 is not going to be a pretty number. Not that bad. 1.83099, but what if we wanted it rounded off to 2 decimal places? We could do that. Let's mess around again. I'm going to make a little loop using a for loop syntax, which we haven't done much with, but that's okay. It's okay for y'all to see something in advance. For parentheses, let's use a while loop. They take a little bit longer to write, but conceptually they're easier to understand. Int x equals 0, colon. While x is less than or equal to 10, in parentheses, curly brace. I've changed my mind. I want to start x at 1. Let's create some variables to hold our answers. Double A equals 1.0 over x. That should have been 1.0. My mistake. Double A equals 1.0 over x. Double B equals POW 9 comma x, like 9 to the power of 1, 9 to the power of 2, 9 to the power of 3, and so on. To get the POW function, if you're using a Windows, it's already included. Else you better include CMath for your Mac users. That reminds me of a quiz question. Let me make a comment. I need to talk about this. Standardlib.h. All right. Anyways, you don't need to put that there. All right. And then let's make up one more. Double C is equal to, I don't know, x, or POW, x comma 9. That's going to get pretty large. Let's just make it x and x squared. All right, now let's write our numbers out. Cout, arrow, arrow, x, arrow, arrow, A, arrow, arrow, B, arrow, arrow, C, arrow, arrow, E, and DL. It's going to be ugly. It's going to be messy. We're not going to like the way it looks. We're especially not going to like the way it looks when it bombs. I'd already defined x up here, excuse me. So let's take out the word int here. Let's just get rid of that. This line had a bug because I'd already defined x up here. So, and I've made it an infinite loop. There's another change I need to make. Why is it an infinite loop? Because x is always less than 10. It never changed. I didn't expect it to print out 1191 infinitely, though. Oh, I guess so, because there's no spaces in it. So, would you please go away? All right. So after we do all those calculations, we need x plus plus here, which your Python users are used to doing is x plus equals 1. Either syntax is valid. X plus plus, increase x by 1. It's called incrementing. And I put that x in the wrong place. That should have gone beneath the print statement. But anyways, we can see that this is real ugly. For one thing, there's no spaces. Now we could go and we could add spaces. And another is that there's way too many decimal points involved. Let's go ahead and add the spaces just before we start trying to format it. And how am I going to do that? I'm going to make a couple of changes here. I'm going to do that. I'm going to do that. And I'm going to do that and that. I'm going to put everything on its own line. And then to each line, I'm going to add arrow, arrow, quote, space, quote, like that. And I'm going to copy and paste that so that there's a space after each piece of data we print. All right, looking better, but it's still ugly, right? It's really hard to read. We could try to fake it out and make it look nice. We could change these spaces to tabs and it might look good. If I add /t here rather than space, I'm probably going to delete this. I'm probably not going to like the way it looks. Might look okay. Yeah, good try. Close but no cigar. We need to do a better job of lining these numbers up. Specifically, we want to do two things. One is that we want to limit the number of decimal points that are being displayed. Like always require only 2 decimal points or something like that. It could be that my formula is getting values too large. I wasn't expecting it to slip into scientific notation like that. And the other thing we want to do is we want to make it minimum width for each column. So we can do both of those. Let's do the minimum first. So to do any of this stuff, you have to do # include angle IO manip, M-A-N-I-P, closing angle. Now let me make sure I get this right, so I'm going to go and look. Set W sets how many characters the data needs to be padded to. Set the width of it. What does padding mean? Adding spaces to it. So if X is 2 digits long, but we had set W, out to 10, then it would print out our 2 digits and then it would pad it out with spaces to be 10 wide. That helps us arrange it in the columns.
What does IO manip do again?
IO manip does all of what we're showing, which is set W for setting width and also controlling the number of decimal places. So it's used for formatting output. Very well worth putting in a comment. IO manip gives us set W, which means set width, for formatted output. And it gives us some other commands too, so I'm going to leave that. I'll be scrolling up here to add additional comments as we do this. Alrighty, so in front of that X, C out, arrow, arrow like that. I'm going to do C out. I'm going to add something in front of all that. Arrow, arrow, set W, parentheses, 10, in parentheses. And then I'm going to take that little bit and I'm going to copy and paste it on every line.
Why there's no semicolon in this line?
We could put semicolons if we wanted to. The reason there's no semicolon is because it's being treated all as one line. right? It's being treated like that with a semicolon at the very end, right? That makes sense? But why don't we word it the way you said, because it's beginning to look kind of ugly, actually. So I'm going to do a little bit more rewriting, as you suggest. I'm going to put semicolons on the end of each line, and I'm going to put C out in front of each line. And then it's going to look a lot more like the code that we normally write. I lost my set W when I did that, so we're going to add it. So set C out, arrow, arrow, set W, parentheses, 10, in parentheses, like that. And I want that to be part of all of our C out statements. So with some judicious cutting and pasting, I don't need it on the last one though, right? Because it's just an end of line marker. I don't care if it occupies 10 spaces on the screen or not. And I apologize because that looks pretty stupid, the way you set that up, and I agree. It's a lot easier in some other languages such as Java and Python.
What is the function \t?
It's the same thing as ENDL. I should have been putting ENDL in there to... Nope, I'm wrong. \T is tab. I can get rid of that completely now because we're using set width to control our spaces. So let's make that change. We don't want tabs anymore. We're controlling our spacing entirely through set W. But yes, that's what /T does, is it does a tab. Just like hitting a tab key on your keyboard. We're getting there. We're getting there. A couple of things to note is that the numbers are so-called right justified, meaning that they line up on the right margin rather than the left. If we don't like that, there's a way to control it with another io_manip command. Another is that we still have too many decimal places, and so the things are getting squished together. And we could go back and we could have changed those tabs to spaces or something like that. We could just try increasing those 10s to 20s. It's going to pad it out too much, right? Change that to a 20, change that to a 20, change that to a 20, change that to a 20. Ah, now it looks good. Now that's too much. I could start reducing the size of those, right? The first one really only needs to be a 2, right? Does not need to be 20 because it goes from 2 to 11. And by the way, it was meant to go from 1 to 10. I put this x++ in the wrong place. See that x++? I should have put it after the print statements. I think I'll do that. I'm going to delete that x++ and I'm going to move it down here to after the last print statement. That way it'll start counting at 1 rather than, okay, that makes sense. Okay, it's looking prettier, but this column only needs to be 2. And how wide is this one? 1, 2, 3, 4, 5, 6, 7, 8, and then maybe 9 for the extra space. So 2 for the first one, 9 for the next one. It'll look better. Maybe I want to increase that 9 a little bit. Maybe I want a little bit more space than just one space between the columns. Maybe I'll make it 12. I think 12 is going to make it look nice. The next one does not need to be 20, right? That's still too wide for it. Maybe I'll make that one 12 wide as well. The last one certainly does not need to be 20 wide because it only goes out to 3. I think I'll try it at 3, but then I may change it if I think it's too crowded. It's a little bit too crowded. And 12 wasn't right, but if these were shortened so that they were all, you know, only showing 2 decimal places, it would look a lot better. Oh, and we should have put 4 spaces here, right? Because our maximum data here is 3, so we want it to be 4. Why don't we just make it 6 or something? I think 6 will make it pretty. It's just, you know, you fine tune it to look the way you want it to. All right, that's the last change I'm going to make to the column widths. But now I want to force each one to print to a precision of 2. Meaning 0.17 rather than 0.166667. Or 0.11 rather than 0.1111. We do that with a different IOmanip command. One thing to note, we had to set the width of each column. You can't just set width once and it picks it up for everything you print after that. You have to set the width for each piece of data you want to control the width of. The next command I show you only has to be set once until you decide you want to change it. So we're not going to have to add it to every cout statement like we did set W. In fact, that is so important, and it's a quiz question that I'm going to put it here. You have to use set W for each and every output you want formatted. Anybody need me to look at your screen? Alrighty. I figured out the x++, which adds 1 to x and saves it, so x becomes 2 and then 3 and 4. We get an infinite loop because x never changes. So that's why we put x++ there. Or in Python, you would have put x plus equals 1. Either one works. Why not just make it plus plus to be like C++ programmers? All right. Now I want to change the precision of it. Set precision x controls how many decimal places we will show. But fixed modifies its behavior. That sounds vague. Yeah, it is vague, so let's go look. Above all of this, set precision only has to be called once until you want it to change. Cout arrow arrow, and this has to be above all of our other couts. Set precision parentheses 3. Want it to be 3 decimal places. And I like the way that looks. It's hiding something though. No. I'm willing to just leave that explanation as it is. And then mention the definition of the other keywords, but not go into them for too much. So we did set precision 3 and limit it to be at most 3 decimal places. I kind of wanted it to show all the zeros always. I wanted it to say 1.000. Let's see if we can get that to happen. Show point, fixed. Let's try those. So cout arrow arrow show point. Let's see if that changes the way it looks. Yeah, that did exactly what I want. I am now happy. Show point told it to always display the decimal points. No, I can't say that that's the actual case. What it's doing now is, if you've taken physics or chemistry, you know the definition of precision, which is the total number of digits. It's not the total number of digits after the decimal point, it's just the total number of digits. And so right now, this is being forced to be a precision of 3. which kind of looks okay, but I really want all those decimal points to line up. So along with show point, I'm going to do C out, arrow, arrow, fixed. All right, and now my output looks really lousy again. I would need to go and modify my widths to get it to work. Why? Because fixed changed those scientific exponent notations to be, non-scientific, just straight representations. And so they've gotten very long. I'm going to totally cheat and just limit it to counting up to 6 rather than 10, because that's about 7 is about where the problem starts, right? Now this is lame to fix it this way, but when I was setting it up, I wasn't really, I guess we could change POW 9 to X to 2 to X. Yeah, let's do that. I'm going to change that line so that we're calculating 2 to the power of X rather than 9 to the X, so it'll be a lot smaller. Hopefully we won't get them to right past the edge of our column. Well, it did, but we can fix that. We just need to set a larger width for the last position, right? Because this can actually go up to 1, 2, 3, 4, 5, 6, 7 characters now. So I need to make it like 8, 9, 10, maybe even 12 like the others. So I just changed this line as well. And we're getting real close to it being what I wanted it to look like. Okay, is that not better than how it looked at the beginning? Yeah, I think it is. What if we wanted only 1 decimal place here, but we wanted 3 decimal places here? Well, that's where it gets kind of tricky, because set precision, once you do it, it stays that way until you change it. So I'm not gonna mess with that, but I could have. I could have gone and done a set precision right here before I printed those 2, and then I could do another set precision that would print out no decimal places. Why not? Why not? I'm going to delete that one. I'm going to put it here, right, in front of those 2 numbers that we're printing out, and then I'm going to put another set precision here saying I don't want any decimal points past that. Or maybe I only want 1 decimal. So now I've just added this line, or I moved it, and now I've just added that line. Now maybe this doesn't need any decimal places at all, right? It's just a whole number counting from 1 to 10. Let's fix that. We're going to use set precision, set it to 0 before we print out X. But then we're going to have another set precision after we print out the first column, going to 3. All right, I could keep playing with it, right? We could keep going. This sure is convoluted compared to how you do it in Python and Java. It's one of the reasons I don't like talking about it too much. But what are the takeaways? The takeaways are set W controls how many spaces, how many columns on the screen you want the next output to fill. Set precision controls how many digits or how many places after the decimal point. Are printed. fixed makes the second definition be true. Forces the set precision to apply to digits after the decimal point. Because if you call set precision 4, but you don't set fixed, then it rounds it off to 4, regardless of whether it's 4.000 or 400.1 or 4,000 with no decimal places at all, right? So instead, we use fixed, and it'll give us 4 decimal places every time. Both set precision and fixed remain in effect until changed, meaning you don't have to call it multiple times, unlike set W. So set W in front of each piece of data, set precision only when the precision needs to be changed. If all of your numbers need 1 decimal point, you call set precision 1 and you're done. You do it once.
Can you scroll up a little bit?
Sorry. Like this?
No, I mean, the bottom text that you were
The
typing
bottom's
there.
hard to read. Yeah,
Thank you.
there. So that's what you use the IO manip for. And I think it's a waste of time to introduce it before we've talked much about loops, because it's really best used to control, you know. On the other hand, we have had some numbers, you know, calculate the interest, and your final result was, you know, $5,100.32546. We might want to round that off to 2 decimals, in which case we want to use set precision. So double interest equals 51 dot, right, like that. I just made up some numbers. You don't have to type my numbers in exactly. Just make them up. And then let's set our precision. Dollars and cents are usually expressed as to 2 decimal points, a number of cents. And we want it to be fixed, meaning we want the 2 decimal places always to appear at the end. And now we can write out our interest. See out, error, error quote, interest earned equals $, end quote, error, arrow, interest. Arrow, arrow, ENDL. And it's going to look a lot nicer than our output would have done if we had not set the precision, right? Oh, I put that inside the loop, and so it's printing it out real stupid. Sorry about that. Take that line, that entire line we typed, and move it to after the curly brace at the end. After this. So cut that out from there. And before the pause statement at the bottom, that's where that needs to be. And now they're build errors. Oh, interest is no longer defined. I should have taken all 3 of those statements. I'm very sorry I made that. I did not mean for this to be a several-step process. All right, the change. Those 3 lines that we added need to be outside of the curly brace of the loop before system pause, if you have system pause. And finally, it's going to look okay. Yeah, so our interest earned, that was the real point of it, is to make it look like dollars and cents rather than 51.435234, which it would have done previously. All right, so about standard line. One of the quiz questions is which library do you use to bring in the random number functions? And then if you Googled it, you'd find out that it was standard stdlib.h. stdlib.h is a C file, not a C++ file. We don't really want to mix C headers and C++ headers unless absolutely necessary. The C++ version of it, for some reason, is C stand lib, like that. You use # include, angle brace, C standard lib, end angle, to get random numbers. And the seed command, fseed or whatever it was called. So, don't pick that one. That one's not mentioned in the chapter. I know why you went out and found it, so I'm sure I gave you partial credit, but I really want you to use that one. All right. So to get the random function and the srand function, which seeds it, you do need the cstand lib, cstd lib header file. That'll get you the point on the exam and on the quiz. Yes, you can find some random number functions inside of standard lib.h, but they don't work the same way. Or if they do work the same way, they're still not. C standard lib is designed to be used in C++. Don't ask me what the differences are. I don't know. I'd have to look. I just know that that's the standard to use for C++. All righty. Anybody getting typos on this loop we have here that you wish would get fixed? We all good? Tell me how high. To that?
Yeah.
Okay. Sure. And how did I pick these numbers? Just trial and error. I kept changing them until I got it to look the way I wanted it to look. Now that we have made all these changes, I guess it's okay to remove these spurious comment indicators. We good? Can I go back to the PowerPoint? All right. So we are done with Chapter 3. So validating user input. What might we check for? We might want to make sure that the value is reasonable. You're writing a program where the nurse is supposed to enter the temperature of the patient. Negative 30 degrees is not a reasonable value for a patient's temperature unless something is really wrong, right? Greater than 200 is not a reasonable, and they are in serious health circumstances if their temperature is greater than 200 degrees. So we might want to make sure that something is in a specific range. We might want to make sure that it's a reasonable value. We might want to make sure that it's a valid menu choice, and we might want to make sure that they don't divide by 0. So at any time we start doing input in our programs, it becomes harder and harder to test. But for example, if you're going to ask for somebody's score, you get the score, and then you make sure that it's greater than the minimum score and less than the maximum score, or greater than or equal to, right? The score has to be between 0 and 100. 0 set to min score, 100 is max score. We want to make sure. And if they enter something that's not greater than or equal to min score, then it's not a good value. You can use a loop to require them to enter a good value, right? We could keep looping until this condition was true. So that's checking for the reasonableness. That's checking for the range. Comparing characters and strings. If you compare two things, they are compared by their so-called ASCII values, which gives us some interesting circumstances. Back in the old days, on your MP3 players, lowercase letters were sorted differently than uppercase letters. Don't know if any of y'all are old enough to have MP3 players that old, but let's give you an example of that. According to the ASCII chart, ASCII-table.com, capital letters have a lower value than lowercase letters, which is the next column. Why? Because capital letters were the first part of the standard, and then later on somebody decided that you might want to use lowercase letters as well. So, if you were sorting things, they sort according to the ASCII values. So, a lowercase a is bigger, according to this chart, than an uppercase b. So if you were sorting your song list, your names or whatever, then at the very top of the list were all the ones that started with lowercase letters, and then underneath it are all the ones that begin with lowercase letters. And the numbers are lower still. So your numbers, if you printed out a list of songs, anything that began with a number would be up at the top, and then anything that began with a lowercase letter would be in the middle, and anything that became an uppercase letters were in the middle, and anything but the lowercase letter was at the bottom. If you're curious about the value, the ASCII value of a letter, you can print it out. Like, say I have a character. Well, let's make a string that holds my name. String name equals, quote, Jeff. You could put your own name. And then char, ch, equals name subscript 0. The subscript just means the first character in it. So it's equal to a J. But I want to know what its ASCII value is. So cout, arrow, int, parentheses, ch, in parentheses, arrow, endl. We're going to find out what the numeric value of that J is. It's a 74. I put it in the wrong place. I didn't put it underneath my interest earned, but it's a 74. And if I go back to ASCII-table.com, what, did I close my windows? Apparently I did. ASCII-table.com. A capital J is in fact equal to a 74. And one more than that, a K is a 75, and then L is a 76, and so on. So I'm going to make another name, and then I'm going to compare to see if one's greater than the other. String name 2 is equal to, quote, Bob. If, parentheses, name 1 less than name 2, cout, arrow, I'm sorry. It was actually just name, right? That's why that's underlined. Cout, arrow, name, arrow, quote, is smaller. \n, end quote, else see out arrow arrow name arrow arrow quote is larger. \n. And by larger, we don't mean the length of it. We mean its values. We want to compare one name to another to determine the alphabetical value. One of them is Jeff. The other is Bob. Is Jeff smaller than Bob? Not according to the numbers. A J is a 74. A B is a 66. I just happen to remember that. So it's not going to say Jeff is smaller. It's going to say Jeff is larger. Let's go ahead and do then Bob, right? Then Bob. And we can get a syntax error. That's what we get. And again, I put this inside the loop, so it's going to print it every single time. I'm going to need to cut that and paste it above the pause statement. But that's not my syntax error, is it?
You missed a semicolon on the last
Yeah, I missed a semicolon here. And all of that should have been above the pause statement. I'm going to come back and grab all of this, cut all of that, scroll down and paste it above the pause statement. And Jeff is in fact larger than Bob. That is a true statement because the ASCII value of Jeff, the numeric value of the J, is greater than the numeric value of the B. And if they matched, it would check the second one. And if they matched, it would check the third one, and so on. Now I'm going to change my name from Jeff to Abe. And that one's no longer going to say it's larger than Bob because the ASCII value of an A is 65. And the ASCII value of a B, if we printed it out, was 66. So in fact, Abe is in fact smaller than Bob. If we were sorting them alphabetically, Abe comes before Bob. The weirdness comes in when you start using lowercase letters. How about a lowercase Abe? It's going to say Abe with a lowercase a is larger than Bob, meaning that when you sorted them alphabetically, Bob is going to be up and then Abe is going to be below it. How do you fix that? Well, one thing you can do is you can just normalize your data by converting everything to uppercase or everything to lowercase before you display it. Another is that you could write a function that takes in uppercase and lowercase into account and use that function. It's looking ugly because I don't have a space in front of the word is. So I'm just going to add a space there and a space there. Then it'll look pretty. Yeah. Resumed it. All right. Yes, sir. Oh, let me come look. As a reminder, never put a semicolon after your ifs or your whiles or your elses. I know in Python you were used to doing that with colons, but we can't in this language. Breaks it. If I put a semicolon there, it starts giving me errors. Like, what is that particular error? If I found it, there were build errors. No, I don't want to run it. Here's the errors, and it says pretty vague. Expected a statement. Well, it looks like a statement to me, right? So you might stare at it for some time before you realize that there should not be a semicolon there. Once you fix that, the rest of these errors go away. So once you fix an error, go ahead and try to run it again. It just doesn't know that the rest of it's fixed, but it is. The conditional operator, this is a weird one. It's also known as the ternary operator because it requires 3 pieces of the expression rather than 2. Ternary meaning 3, it's binary meaning 2. Here's the way it works, is it tests this condition. And if this condition is true, it executes the first thing after the question mark. If this condition is false, it executes the second thing, the thing after the colon. So like this. Above my pause. Lost it. Come back down here. Temperature, int temperature equals 120. It's really hot. String s equals, and now we're going to do our test. I'm going to put parentheses even though the parentheses aren't necessary because I think it makes it easier to read. So inside the parentheses, temp greater than 100, in parentheses question mark. So is temperature greater than 100? I want hot, end quote, colon, that's a colon, not a semicolon, quote, not hot, end quote, semicolon. And then we could print that out. Cout temp error, wait, cout error quote, no quotes, cout error temp error quote space, and then the word is followed by another space, end quote error s error endl. And it's going to say 120 is hot. But if I edit it to something that's not greater than 100, it's going to say it's not hot. How about we change hot to cold, not hot to cold? I don't like that not hot word. I'm going to change that to cold. All right, and so 120 is in fact hot because it's greater than 100, but what if we change our temperature to 99? It's no longer greater than 100. And so 99 is cold, according to our definition of hot and cold. The way we read it is the thing in front of the question mark is evaluated to true or false. And if it's true, it's the thing after the question mark. If it's false, it's the second thing, the thing after the colon. And that just gets copied across the equal sign like that. Now the textbook shows you a really weird way of using it that works in this language but not in some other languages. I'm not particularly fond of it. And that's doing exactly what this shows. I'll bring the code back in a second, but let me show you this first. Is x less than 0? It sure is, so let's set y equal to 10. Else set z equal to 20. Now that syntax would not work in Java or a whole bunch of other languages, but it does work in C++. So that's fine if you want to do that. But this is the more common nomenclature for it. I don't need these parentheses. I could take these parentheses out and it would work just as well. I think it makes it easier to read, just like you put parentheses around your if clauses and your while clauses.
Can you explain the question mark?
That's what I'm doing.
Oh, sorry.
The question mark is called the ternary operator, the conditional operator, and what it does is it tests the expression before the question mark. And that wasn't meant to be snarky. This is what we're trying to explain is how it works. Everything before the question mark is evaluated, and if it's true, then it does the thing after the question mark, the first thing after the question mark. And if it's false, it does the second thing. So if temperature is greater than 100, is it? Question mark? But if it is, then hot gets copied into the string. Else cold gets copied into the string. Rewriting that, it would look like this. It's the same as this code. If temperature greater than 100, S equals, quote, hot, semicolon, else S equals, quote, cold. Those two statements are equivalent. This is just a way of writing it in a short, succinct nomenclature. I think it makes it harder to read, honestly. When I was a pro programmer, I very rarely chose to do that because I think it makes it harder to read. But if you're a pro programmer and you've seen it enough, then it makes it easy to read. But at first it's a little bit maudlin. Does that make sense? 100% sense, 50% sense,
90.
90, all right. So one more. See out, wait. Yeah. Temp less than 0, question mark. See out, arrow, quote, cold, exclamation point. End, \n, end quote, colon, and I would never do this. I think this is horrible. And it's giving me error messages. It's so horrible. I would agree with that. Forget it. I don't want to do that. I'm erasing the whole thing. This slide here works. If x is less than 0, it sets the value of y to 10. Else it sets the value of z to 20. Both of these are appropriate ways of using the conditional operator. So the way you read it is that the conditional expression is evaluated, and the result is the thing after the question mark if it's true, or it's equal to the last thing if the thing in front of the question mark is false. Parentheses may be needed in an expression due to precedence of conditional operators. That's vague and they don't give an example of it. But just as a matter of course, when I'm writing these programs, I always do put the parentheses in front of the question mark because I think it makes it easier to read. And they're claiming that that's useful to also handle precedence. All right, about time to stop this lecture. We almost made it through chapter 4. I really wanted to have made it longer, but all right, the switch statement, we're skipping that for now. Not going to be on the exam. We'll cover it on Thursday, but I'm not going to throw it in the exam because I try not to ever put anything on an exam that we only covered last class period. Yep. So we are done with the chapter, except for the switch, which I will cover on Thursday. Okay, so homework. What's a good, appropriate chapter 4 homework?
Exam in next Tuesday.
Exam is next week. That's correct. That's correct.
Can I take it on the testing center?
You can take it at the testing center and skip coming to class if you want. You just better tell me to do that and so that I'll go and take the paperwork to them. Do you want to do that?
Yes.
You'd rather take it at the testing center? Okay.
And can I take it on or before April 2nd?
You can take it. We'll make it open on Monday and close on Wednesday at midnight. So you can take it Monday, Tuesday, or Wednesday. Is that okay?
Yes.
All right. All right, since that homework assignment most people did not do because they didn't have a place to upload it, I don't feel like giving y'all a great big homework assignment for today. But let's take a look at this one. There's a lot of explanation here, and it's not really as long as the explanation makes it look. It's just a couple of if statements. So here's the explanation. Electromagnetic radiation has properties based on the wavelength of it. If you've never taken physics, you don't care. But something with a really high wavelength has got a lot of energy. Something with a really long wavelength doesn't have as much energy. So ultraviolet light's really bad, can burn your skin because it's got, you know, high wavelengths. Or a short wavelength, a high frequency. And infrared waves, heat, aren't nearly as bad. because they have a long wavelength. Means they have a short frequency. So, the colors. Violet is based on a certain wavelength, certain range of frequency. Blue is a different wavelength, different frequency. As the frequency goes up, the wavelength decreases because it's bouncing faster and faster and faster. All right. So, for this problem, we can ignore the frequency column. We can ignore the photon energy column. So, now we're only dealing with the colors and the wavelengths, and we're going to be checking. If the wavelength is greater than or equal to 380 but less than 450, we want to print violet. Else, if the temperature, the wavelength falls in this series, we want to print blue. Else, if it falls in this series, we want to print green. Just like a score program, right? 90 and above is an A, 80 and above is a B, 70 and above is a C, and so on. So you're going to use if statements to handle it. You're going to ask them for the wavelength, and then you're going to display what color that is. So, if the value is less than 380 or greater than 750, it's not even visible. It's ultraviolet or it's infrared, it's X-rays or something like that. It's off the map of the visible wavelength. So, if it's less than 380 or greater than 750, you're going to print not visible. Otherwise, it's going to print whether it's violet, blue, green, yellow, orange, or red based on its ranges. And we'll cover that again on Thursday, right? Because this isn't due for a week. Maybe I'll make it a week plus 2 days. That sounds reasonable. But I want to go ahead and post it. All right. That makes sense? Even if we're not physics majors?
Makes sense to me.
Good. Yeah, but I can tell you're a physics major. No, I'm kidding. All right. So I think we're done for today. We'll do a review on Thursday.
Do you
Let's make a Dropbox for it. Yep.